Hi everybody, and welcome to the video for Monday, February 9th. In this video, all I want to do is finish up what we started with if statements in the last video. So there are two topics we still need to address. The first topic is having an if inside of an if, so having nested if statements. There's certainly nothing intrinsically wrong with doing that, so you can certainly put ifs inside of ifs if you want to. And I just want to talk about the logic of doing that and why you would do that. And then we need to talk about some more Boolean statements, some different ways of handing if statements something Boolean that they can test. So we'll need some new terminology and some new symbols to finish up the section on Boolean statements. So that's what we're going to do. And so here's just a motivating example. Suppose that you want to write a program that lets people play chess or checkers. And additionally, each game has a hard mode and an easy mode. How would you think through writing code that would do this? That would let a user choose which game to play and then choose whether or not they want to play hard or easy. Well, the code would go something like this. You would ask the user, do you want to play chess or checkers? And depending on what they enter, you would enter a particular block of code. If they entered chess, you would enter the chess block. If they entered checkers, you would enter the checkers block. Okay, once you're inside each of those blocks, now you can ask them, well, do you want to play hard or easy? And so now you have another conditional thing there. So if they say hard, you should do the hard code. If they say easy, you should do the easy code. Okay, so to do that though, you have an if inside of an if. The if that tests whether it's hard or easy is inside of the if for checkers or chess, depending on which branch you're inside of. And so before I show you the code, let me just tell you the visual you should have in your head is the following. Whenever you write an if and then maybe an else if, whatever, when you have an if followed by different else ifs and maybe an else, what you're doing is you're giving the computer different branches that the program can go down, and each of the branches is mutually exclusive. You can't go down branch 1 and branch 3. That's not how the code works. So when you have that first if statement, you're giving the computer different paths that can go down, different branches. Well, branches can have branches, right? Branches themselves can branch. So once you're inside one branch, that branch can also branch off using an if statement, and those branches themselves can branch off too if you want to. So every time you introduce an if inside of an if inside of an if, you're just introducing a branch or a series of branches to a branch that already existed. So it's just giving the computer more branching options. So here's what the beginning of the code looks like. So what game do you want to play? You store their response in response 1. And then if, oops, there's a typo there, right? Should be a 1 right there. But anyway, if response 1 is checkers, then you say let's play checkers, right? Enter 1 for easy and 2 for hard. And so you save that as an integer x. And then notice another if, right? If x equals 1, then you're a coward for choosing easy. But if x equals 2, then let's get that on, right? Let's do this. So notice, right, you had a branch up here that branched into checkers, and inside of the checkers branch, you had 2 more branches for either easy or hard. And the screen isn't big enough to show the rest of the code, but what you would do to do the chess branch now is, beneath all of this, you would have, else if response 1 equals chess, then you would have basically the same code except you'd replace a checkers with a chess. So it just won't fit on the screen, but here's how the logic of the first part of the code works. So in conclusion here for this screen, you can have ifs inside of ifs if you want to. Whether you do that or not is dictated by what you want the program to do. Okay, so now let's move on to some more Boolean statements. So to motivate this, suppose you're writing a program, you ask the user, do you want this program to run, or you ask them anything, right? Do you want this program to do this or that? If the user enters yes, the program should run. But if the user enters a capital YES, then the program should also probably run, right? You probably don't want to have the program quit just because they capitalized that first Y. So the logic of what's going to happen here is the following. You want to set up a statement that says this. If the user says lowercase yes or uppercase yes, then please run the code. Otherwise, don't. And so This is not what you write, by the way, but this is the English of what you would write. So string response, get their response, and then if that response is yes or uppercase yes, then do your stuff, right? This is the logic behind what you want to have done here. Unfortunately, C++ does not recognize the word or. That's not a reserved word in C++. So this code, as I've written it, will not run. The way you get it to run is to use C++'s version of OR. And to write an OR in C++, you do vertical bar, and that's the key on my keyboard anyway. Right above the enter key, you do shift \, and it will give you that vertical line. So you can never write the word OR. You have to use this \. And also, if you just replace this OR right here with these two vertical lines, it still won't run. And the reason is because you have to literally tell it if response is yes or response is this yes, then run. And the way that looks is like this. If response is lowercase yes or response is uppercase yes, then do your thing. So you always have to tell it what variable you're comparing this thing on the right to every time. So you have to write the full statement every time. So it's kind of obnoxious, but that's what you have to do. You'd like just to be able to put the two vertical bars there, but C++ will not let you. Okay, so you can write an OR in C++. Unfortunately, the word AND is also not reserved, so you need a ampersand as the way you write that. And the word NOT is also not reserved. The way you write NOT in C++ is with an exclamation mark. So, if you want to tell the program, if the user doesn't do this, right? If they don't say that, then do this chunk of code, right? If they don't do this particular thing, then do this chunk of code. So the way you'd represent that NOT is with this exclamation mark. Okay, so let me give you a couple of examples with these symbols. So here's something that if you read it in English makes perfect sense. If 1 is less than or equal to x is less than or equal to 6, that makes sense to you, right? What you're saying is that if x is between 1 and 6, and also possibly 1 or possibly 6, then do your thing. Unfortunately, C++ does not recognize this. This statement here, this 1 is less than or equal to x is less than or equal to 6, that's actually an AND statement, if you think about it. What you're literally saying is this. If x is bigger than or equal to 1, and x is smaller than or equal to 6. That's what you're literally saying in English. And so that's the way the computer wants you to write it. So it will not run this. It doesn't know what this means. But it will run this. It knows what you mean here. Oh, values between 1 and 6. Okay, so there are several common mistakes, and I'll just address a few of them. Like pretty much any kind of code in this course, you just have to write code yourself until you get comfortable with it. So just because I tell you about these mistakes, you'll probably still make them. That doesn't matter, right? You just have to write enough code until you can avoid it. But here's one mistake I see. People confusing AND and OR. So here's an example. Do you want to play this game? Yes or no? If you get their response, what you'd like to happen is if they enter this little y or this uppercase Y, you would like for the game to run. Notice though I put an AND in between. So what is this literally saying in English right here? It's saying if the response is a lowercase y and the response is also an uppercase Y, then do the if statement, right? And so notice that this statement here is always false. You cannot be simultaneously a lowercase y and an uppercase Y. You cannot simultaneously be two different strings. Okay, that's a contradiction. So the computer will never enter this if block if you use ands here, because it will just ask, is this statement true? No, the statement's false, right? Contradiction, and it won't go through the if statement. So what you really want here are ORs, the OR bars. If response is little y or the response is big Y, then do what's inside the if block. Okay, before we move on, we need to deal with a little bit of logic. I don't know how many of you have had a logic class or not. It doesn't really matter, but for those of you who haven't had a logic course, here's something you need to know. Consider the statement A or B. So a statement like, it's raining or I'm going to the store, right? just a statement with an or in the middle. When is such a thing true? Well, if A is true, then this statement is true. Okay, so if A is true and B is false, this or statement is still true. If B is true, then this or statement is true. So if B is true and A is also false, that doesn't matter. The or statement, the combination of the two, is still true. If A and B are both true, then A or B is true. Okay, so when you write an or statement, if either of the components are true, then the overall statement is true. So here's an or statement. I'm the best professor ever, or it's 110 degrees outside. Okay, suppose I ask you, is this statement, this overall statement, right, this single English sentence, is that true or false? Well, it comes down to whether or not this individual statement is true, or this individual statement here is true. So it is not 110 degrees outside right now. So this statement right here is false. This statement right here, though, is true. So since one of the individual statements is true, the overall or statement is true. Okay, so this whole statement here, you would have to give it a truth value of true. By contrast, if you say A and B, when is that kind of statement true? If and only if both A and B are true. So it is more difficult for an and statement to be true than an or statement. It's easier for ors to be true because only one of the statements has to be true. But for an and statement to be true, both of the individual components must be true. So keep that in mind as we move through the next couple of slides. So here's that chunk of code we just had a second ago, right? Enter 1 for easy and 2 for hard, and then you get a number. Well, what if the user mistypes and they enter a 4 or a 7 or whatever, right? What would you like the program to do? Well, you'd probably like the program to say, I didn't recognize what you just entered. That's not a valid input. Please try again, something like that. So notice that this is a way of representing the valid inputs, the inputs you're expecting. You're expecting either a 1 or a 2 for x. Right, so either x is 1 or x is 2. Therefore, to represent the invalid inputs, you expect not that. So not x equals 1 or x equals 2. Those are the invalid inputs, right? Here are the valid ones. So the not valid ones are the not, right? Exclamation mark is not, are the not valid ones. So how would you hand this to the computer? You don't hand it to the computer like this. What you use, you simplify it, first of all, and the way you simplify this not parentheses statement is using something called De Morgan's law from logic. And what De Morgan says is, he says if you want to have an or statement and then negate it, take the not of it, you can do it. The thing is the or now turns into an and then you negate the individual statements. So not A and not B. So here's an example. Consider the statement, my name is David or my name is Mark. If you wanted to negate that, the logical negation is my name is not David and my name is not Mark. So I've negated each of these individual statements here. My name is David, my name is Mark, and then I changed the or to an and. Okay, so in the first statement, this statement inside the parentheses is true if my name is David or my name is Mark, right? And my name happens to be David, therefore this statement inside here is true. But anyway, when I negate it, now what I'm saying is that neither Mark nor David is my name. Okay, so my name is not David and my name is not Mark, right? So both of those things have to be true. I've turned an or into an and. So back to our example, what you'd like to tell the computer or the user, if they enter a 3 or a 7 or whatever, you want to tell them, please try again. So what you need is a way to represent this statement, the set of invalid statements, to have the computer check whether somebody entered something invalid. Well, by De Morgan's law, not of that or statement is an and. So what I have to do is negate this statement here, x equals 1, negate this statement here, x equals 2, and change the or to an and. Well, if I want to negate x equals 1, the opposite of that is x is not equal to 1. And that's what this is saying. X is not equal to 1. If I want to negate x equals 2, then I do the negation. I do the not of that. X is not equal to 2. And then I put an and in between. So here is a representation of invalid inputs. So if they enter something that's not 1 and also not 2, then you should tell them that's invalid. Okay, so let me show you a common error I see when people are doing this. So let me go back, right? Notice, x is not equal to 1 and x is not equal to 2. What I'll see sometimes is this, x is not equal to 1 or x is not equal to 2. And then people will say, that's an invalid input. Okay? So if you believe what I said on the last slide, that this is the way you write, if you want to catch invalid inputs, that's the way you write it. If you believe what I said, then something must be wrong with this. Okay, this can't be the way that you're going to catch invalid inputs. And of course something is wrong with this, so let me explain what's wrong. Suppose the user enters a 1 for easy, right? And now x is 1 right here. Well, if x is 1, then this statement right here is false, right? Because this statement says x is not 1. So if x is 1, this statement is false. But if x is 1, this statement is true, okay? Because 1 is not equal to 2. Okay, so what's happened here? This statement is false, but this statement is true. And remember, for an OR statement to be true, you only need one side of it to be true. Okay, you only need one of the individual statements to be true. So if I enter a 1 right here, this overall OR statement is now true because 1 is not equal to 2. And so you will enter the if block, and it will tell you you entered something invalid, even though you entered something valid. Okay, so maybe that's confusing, so let me say this one more time. If a user enters a 1, now the computer has to decide whether or not this statement here is true. Well, for an OR statement to be true, you only need one side of it to be true. And in particular here, this side is true, because 1 is not equal to 2. That's a true statement. So the computer decides that this overall OR statement is true, and therefore it enters the if block, and it will output this invalid input. Okay, so the program won't act like you want it to act like. Oh, so I said, okay. So just continuing the thoughts with De Morgan's law here, we talked about when you take the not of an OR, it turns it into an AND. The opposite also works. If you take not of an AND, then you get an OR. So if you want to put that not inside and distribute it, then you negate each individual statement, not A, not B, but then you change the AND to an OR. So consider the statement here, I had pizza for dinner and I drank Dr. Pepper, right? The opposite of that statement is, I didn't have pizza or I didn't have Dr. Pepper. Okay, so you change the and to an or and you negate the individual statements. Okay, to finish up this video, I just wanted to briefly put all this together. So I want to run a program here, and I want to let you try to guess how this program was built and see if you can see the branching going on with the nested if statements, and see if you can think about what kind of Boolean statements are in play here. So what this program does is it mimics interactions I had with women in high school and college. And so the computer speaks in my voice. This is me approaching somebody, right, in my real analysis course or whatever, and saying, do you want to go out with me, right? So now I'm going to enter various things that the woman might have said. So this didn't really happen, but we'll play along for the program, right? So she says yes. Here's my response, right? Oh, you're willing to date me? Marry me, right? You got to hop on that real fast. Come on real strong, right? So the program ended though, so let me show you another response. She may have said yes with a capital Y, right? My response would have been the same, right? And the program just ends. So if she says yes in some form or fashion, then I come on real strong. But suppose, you know, let's be real here. Suppose she does what they all did, and she says no. Well, now it doesn't say, OMG, I love you, right? Now it says, but why? Right? It asks a follow-up question. And she could say a few things. She could say something like this, my only feeling for you is pity. And my response was this, I can work with that. You know, that's usually how I get a date. You know, oh, you feel pity? So you're saying you have feelings for me, right? I mean, it's not so bad. And then the program ends. She could have said no with a capital N, and notice the follow-up question is still the same. And she might have said this: I don't like mathematicians. That's a hard word to spell. And here's how I respond: you plus me equals us, right? Which is a bad response because she just said she doesn't like math people, and then I sort of doubled down on my math strategy here, right? And then the program ends. So she could have said something like this: Stop asking me, right? But why, right? Why are you saying this to me? She could have said like this: I'm not attracted to you, right? And here's my response: What was that? Couldn't hear you, right? Couldn't hear you over my tears. Hold me. So that's all the program does. Oh no, let me show you one more thing. So she says gibberish, right? Invalid input, please try again, right? Or she says basically anything else. You know, the program is not very sophisticated. It says that. So let me show you the logic here. So I get her input, right? Do you want to go out with me? And I have to use a get line because she might use more than one word. If she says lowercase yes or uppercase yes, then I make my real strong move here, right? I can't help myself. You know, been so long, right? Otherwise, if she says lowercase no or uppercase no or stop asking me, then I ask her a follow-up question. And now the program branches again, right? If she says my only feeling for you is pity, oh, and I rewrite over input, right? So I gave input a value up here. She entered a value up here. But now down here, I overwrite what was there. So suppose that she originally said no. Input has no all the way until right here, and then I overwrite it with whatever she says next. So maybe she says next, you know, my only feeling for you is pity, right? Oh, that's fine. You have feelings for me. Or she says, I don't like mathematicians, right? And then I say my little math thing. I'm not attracted to you. And then I cry. Otherwise, if the input is none of those, so not equal to yes, not equal to that yes, not equal to no, not equal to uppercase no, not equal to stop asking me, then it says invalid input, please try again. And so notice I could have branched this even more, right? Like suppose I wanted to keep asking follow-up questions, assuming she kept talking to me, right? Like, you know, so like right here I could have said, oops. I could have said something like this. Let me put braces around here. I could have said, you know, how about a pity date or whatever, right? And then I could have gotten her response again. And then, you know, if she still says no, I could, you know, whatever. Something like this. You see, so there's an if inside of it. So this if is inside of this if, which is inside of that if, right? So you can just keep doing like this. You can keep nesting them as much as you want. Oh, sorry. Here. And so then I could keep going, right? You can nest as often as you want. It starts getting pretty complicated if you have, you know, 10 nestings. But anyway, the logic just goes like you just keep branching and branching and branching. And so for now, we're done with if statements.